I was 180 when this quarantine started. I've been eating really well and exercising, and now I'm over 800.
You're going to find that units are a big deal in physics. We're used to a bunch of units that aren't really helpful in physics, and here's why. We base everything we do this year in high school physics on three main quantities: mass, length, and time. We can get other quantities from those. Think of how fast you're going in meters per second. That's a length per unit time. So we want to measure those things using measuring units that are convenient. And by convenient, I mean we want to be able to convert up, measure big things, measure small things. And we also want to feel for what those units represent. It shouldn't be that bad. Let's look at what we're used to. First of all, seconds. The good news is we use that as our primary unit in physics also, seconds. The bad news is seconds, well, if we're talking about something very long, a year, how do you convert seconds to years? It's not that easy because there's 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, however many days in a year, however many years in a, well, it goes on. So the conversions are really quite difficult. But that's what we go with, seconds. That's the universal thing. We're going to use a concept called Système International, SI units. And seconds is the SI unit for time. The second one, if we think about length, what we measure in is inches and feet and yards and miles and so forth. Well, an inch is based on the width of a man's thumb. Oh my gosh. And if you look, the width of my thumb is pretty close to an inch. It's hard to do backwards there, but pretty close to an inch. In fact, in a whole lot of languages, the word for thumb and inch are very, very similar. So in Spanish, I think it's pulgado and pulgar. For Dutch, it's duim. I think that's the same for both inch and thumb. Same for an awful lot of different languages have that same feature. That's nice. Hey, there's an inch. It's very easy for me to think about what an inch means. What's not so nice is inch actually comes from the word for 1/12, I think, in Latin or Greek or somewhere like that. 1/12, and that's what's kind of bad, is when we talk about bigger things, we've got to talk about feet and yards and miles. Oh my gosh. 12 times 3 times 1760. Those are not good conversion factors. Those don't make it easy. So inch we don't want to use. What we want to use is this thing called a meter. And here's a meter stick. We roll back, and a meter stick it's kind of close to a yard. And a meter, for me, it's really kind of straightforward. It's from the center of my chest to the farthest point on my fingers, but I'm 6'4". Oh, I didn't use metric. And so I'm like I don't even remember how many meters I am tall. But it's easy for me to get a feel. I want you to get a feel for what a meter stick is, what a meter of length is. And if you're doing this remotely, boy, that's a little harder. It's going to be a challenge. But measure it out. Figure out what a meter is. A meter is about 39.25 inches. We don't really do that conversion a whole lot in this class. Once we get into meters, you can see it's really easy. Here's why. It's something really small. I've got a very small adapter for a micro SD drive. Well, I can measure that, and I'm going to take my stick here, and I can measure it, and it's about 3.1 centimeters. Centimeter is 1/100th of a meter. So to convert big and small, to get that in meters, 3.1, I just have to move the decimal place, and we'll talk about conversions later. But it's much easier when you're just moving decimal places rather than multiplying by 12 and 36 and 1760. So big things, kilometers. Kilometer is 1,000 meters. We move it 3 decimal places. So it's really easy to convert. So far, seconds for time, meters for length. Those are our SI, Système International units that we use in physics. Kilograms. Mass is something you've probably never worried about. You probably haven't measured. It's a little tough. We don't really use the concept of mass until we get to physics. We don't really measure mass in a whole lot of other ways. And when people do, they generally make some mistakes. A kilogram is how much stuff there is. A kilogram is actually the mass, how much matter, how hard it is to move a volume of water that's a liter big. This is a liter. So a kilogram is like a liter bottle of water. How hard it is to move it back. It's a measure of how much stuff there is to move back and forth. I'm really screwing it up because mass is a difficult concept. So a mass, amount of mass on Earth would have a certain weight, and we'll talk about that when we get to weight. But mass is really sort of the amount of matter. And the amount of matter in this 1 liter liquid is about a kilogram. If you were up in space and you did this, you'd still have to work. You'd still have to use your muscles to push it back and forth to change its motion. That's an indication of the fact mass is amount of matter, how hard it is to move it. And a kilogram, there's your kilogram. A kilogram is that much liquid is about a kilogram of water. And the nice thing about, another thing that's a little scary about this is kilogram. You'd think the normal unit that we use, the basic unit we'd use would be gram. It's not, it's kilogram, because this is much easier to get a sense of touch and feel, how much there is. But it's still very easy to convert. So if I measured something and I said this SD drive is 1.5 grams, all I have to do is move it 3 decimal places to get the number of kilograms, 0.0015 kilograms. So it's very easy. This is what we're talking about with units. Be good with the SI units. Know that the SI units are meters, seconds, and kilograms, not grams, kilograms, for length and time and mass. And we will, as the year goes on, we will build up on those units. So for example, the unit for speed or velocity, meters per second. The unit for acceleration, meters per second squared. The unit for force, how hard something is pushed or pulled, that's actually newtons, but a newton is a kilogram meter per second squared. Every time you make a measurement, every time you make a calculation, every time you use an equation, you want to know what units you're dealing with. So when I got on the scale and I saw that I had a weight of 800, that was actually newtons. My weight in pounds is about 180, and it turns out those were 2 equivalent things. So during quarantine, I didn't gain whatever that was, 620 pounds or 620 anything. I really just measured the 2 things separately, my weight in pounds and my weight in newtons. One other good thing about kilograms is it makes it really easy to convert to weights. We don't really have in the English system, I think there's a thing called slugs. That's the unit for mass. We never use it. This kilograms is the thing that allows us to do an awful lot of calculations really fast. And you should be very happy that we're using the SI system.